The Surya Siddhanta is the name of multiple treatises in Hindu astronomy. The extant text as edited by Burgess is medieval, but it is clearly based on older versions, thought to have been composed in the early 6th century AD. It has rules laid down to determine the true motions of the luminaries, which conform to their actual positions in the sky. It gives the locations of several stars other than the lunar nakshatras and treats the calculation of solar eclipses as well as solstices, e.g., summer solstice 2106. Significant coverage is on kinds of time, length of the year of gods and demons, day and night of God Brahma, the elapsed period since creation, how planets move eastwards and sidereal revolution. The Earth's diameter and circumference are also given. Eclipses and color of the eclipsed portion of the moon are mentioned. Textual history and influence. In a work called the Pankha Siddhanta, composed in the 6th century by Varahamihira, 5 astronomical treatises are named and summarized: Purusha Siddhanta, Ramaka Siddhanta, Vasatha Siddhanta, Surya Siddhanta, and Pitamaha Siddhanta. Judging from the epoch dates in the work, Plavka suggests that this Surya Siddhanta was composed or revised in the early 6th century. Uppala, a 10th century commentator of Varahamihira, quotes 6 shlokas of the Surya Siddhanta of his day, not one of which is to be found in the text now known as the Surya Siddhanta. The present version was modified by Bhaskaracharya during the Middle Ages. It is partly based on Vedanga Jyotisha, which itself might reflect traditions going back to the Indian Iron Age. It is hypothesized that there were cultural contacts between the Indian and Greek astronomers via cultural contact with Hellenistic Greece, specifically the work of Hipparchus. There were many similarities between Surya Siddhanta and Greek astronomy in Hellenistic period. For example, Surya Siddhanta provides more accurate and detailed table of signs than Hipparchus. However, the epicyclical model of Surya Siddhanta was simpler than that made by Ptolemy in the 2nd century. The table of signs may reflect the only extant version of the original table by Hipparchus, which was lost in the West, but which underwent tradition within Indian astronomy for at least a millennium before reaching its extant form. Because the tradition of Hellenistic astronomy was essentially stopped short in the West after the end of late antiquity, the Surya Siddhanta came to play an important part in the history of science, as its survival allowed transmission of the knowledge of trigonometry into Islamic astronomy and from there back to medieval Europe by the 12th century. Surya Siddhanta was one of the 2 books in Sanskrit translated in Arabic in the later half of 8th century during the reign of Abbasid Khalifa al-Mansur, and was one of the first books to be translated during the movement for translating world heritage in Arabic. Contents. Astronomy. The table of contents in this text are: the mean motions of the planets, true places of the planets, direction, place and time, the moon and eclipses, the sun and eclipses, the projection of eclipses, planetary conjunctions of the stars, risings and settings, the moon's risings and settings, certain malignant aspects of the sun and moon, cosmogony, geography, and dimensions of the creation, the gnomon, the movement of the heavens and human activity. Methods for accurately calculating the shadow cast by a gnomon are discussed in both chapters 3 and 13. Time cycles. The astronomical time cycles contained in the text were remarkably accurate at the time. The Hindu time cycles, copied from an earlier work, are described in verses 11 to 23 of chapter 1. 11. That which begins with respirations is called real. 6 respirations make a vinadi, 60 of these are nadi, 12, and 60 nadis make a sidereal day and night. A 30 of these sidereal days is composed a month. A civil month consists of as many sunrises, 13. A lunar month, of as many lunar days. A solar month is determined by the entrance of the sun into a sign of the zodiac. 12 months make a year. This is called a day of the gods. 14. The day and night of the gods and of the demons are mutually opposed to one another. 6 times 60 of them are a year of the gods, and likewise of the demons. 15. 12,000 of these divine years are denominated a Khator of 10,000 times 432 solar years. 16. Is composed that Khator with its dawn and twilight. The difference of the Kriya Yuga and the other yugas, as measured by the difference in the number of the feet of virtue in each, is as follows. 17. The 10th part of a Khator multiplied successively by 4, 3, 2, and 1, gives the length of the Krta and the other yugas. The 6th part of each belongs to its dawn and twilight. 18. 1 and 70 Khator make a Manu. At its end is a twilight, which has the number of years of a Kriya Yuga, and which is a deluge. 19. In a Kalpa are reckoned 14 Manis with their respective twilights, at the commencement of the Kalpa as a 15th dawn, having the length of a Kriya Yuga. 20. The Kalpa, thus composed of 1,000 Khator and which brings about the destruction of all that exists, is a day of Brahma. His night is of the same length. 21. His extreme age is 100, according to this valuation of a day and a night. The half of his life is past, of the remainder, this is the first Kalpa. 22. And of this Kalpa, 6 Manas are past, with their respective twilights, and of the Manu son of Evasvant, 27 Khator are past. 23. Of the present, the 28th Khator this Kriya Yuga is past. Planetary diameters. The Surya Siddhanta also estimates the diameters of the planets. The estimate for the diameter of Mercury is 3008 miles, an error of less than 1% from the currently accepted diameter of 3032 miles. It also estimates the diameter of Saturn as 73,882 miles, which again has an error of less than 1% from the currently accepted diameter of 74,580. Its estimate for the diameter of Mars is 3,772 miles, which has an error within 11% of the currently accepted diameter of 4,218 miles. It also estimated the diameter of Venus as 4,011 miles and Jupiter as 41,624 miles, which are roughly half the currently accepted values. 7,523 miles and 88,748 miles, respectively. Trigonometry. The Surya Siddhanta contains the roots of modern trigonometry. Its trigonometric functions Jya and Koti Jya are the direct source of the terms sine and cosine. It also contains the earliest use of the tangent and secant when discussing the shadow cast by an gnomon in verses 21-22 of chapter 3. Of the sun's meridian zenith distance, find the Jya and Koja. If then the Jya and radius be multiplied respectively by the measure of the gnomon in digits, and divided by the Koja, the results are the shadow and hypotenuse at midday. In modern notation, this gives the shadow of the gnomon at midday as and the hypotenuse of the gnomon at midday as, whereas the measure of the gnomon is the radius of the gnomon, is the shadow of the gnomon, and as the hypotenuse of the gnomon. Calendrical uses. The Indian solar and lunisolar calendars are widely used, with their local variations, in different parts of India. They are important in predicting the dates for the celebration of various festivals, performance of various rites, as well as on all astronomical matters. The modern Indian solar and lunisolar calendars are based on close approximations to the true times of the sun's entrance into the various races. Conservative Panchang makers still use the formulae and equations found in the Surya Siddhanta to compile and compute their Panchangs. The Panchang is an annual publication published in all regions and languages in India containing all calendrical information on religious, cultural and astronomical events. It exerts great influence on the religious and social life of the people in India and is found in most Hindu households. Editions. Translation of the Surya Siddhanta, a textbook of Hindu astronomy, with notes and an appendix by Ebenezer Burgess, originally published Journal of the American Oriental Society, 6 141-498. Commentary by Burgess is much larger than his translation. Surya Siddhanta, a textbook of Hindu astronomy by Ebenezer Burgess, ed. Fanindralal Ganguly, with a 45-page commentary by P.C. Sengupta. Translation of the Surya Siddhanta by Bapu Deva Sastry, ISBN 3-76481334-2, ISBN 978-3-76481334-5. Only a few notes. Translation of Surya Siddhanta occupies first 100 pages, rest is a translation of the Siddhanta Siromani by Lancelot Wilkinson. Surya Siddhanta Sanskrit text in Devanagari. This page has been deleted and transferred to the following.